This is John Fellenstein, Professor Polymer from the University of Akron with another daily demonstration. So in our last video, we took some pre-stretched polystyrene sheets and we made them shrink into forms, and we made these nice little decorations called Shrinky Dinks. Today we're going to use the same material, but we're going to create three-dimensional shapes from these flat sheets. This is called self-folding polystyrene sheets or self-folding Shrinky Dinks. This process was first developed by some folks down at North Carolina State University, Professor Michael Dickey in the engineering department there. And so we've adapted that, and they actually have provided us with lots of resources so we can use these for our outreach as well. So thank you, Dr. Dickey. Self-folding is a process that causes predefined two-dimensional template to fold into a desired three-dimensional structure with high fidelity. Self-folding takes advantage of the multitude of available 2D patterning techniques like inkjet printing. Self-folding may be useful for packaging, actuation, and sensing. It's also something that would be quite helpful, I think, if we were to develop a permanent outpost on Mars. We could take flat, pre-folded materials, have them assemble themselves on site. So let's see what it looks like when you have a self-folding Shrinky Dink. Okay, so here's my setup. I have a hot plate with an aluminum piece of aluminum plate on it so that it gets evenly hot. And what we can do is we can take a piece of the Shrinky Dink material. Now this is just a little strip, and I drew a black line on it. So if we set that on there, we can also use a thermometer to figure out what our temperature is. Now we want to get it very close to the actual temperature where the Shrinky Dink is going to shrink itself. But then we're going to hit it with a very bright light and see what happens with that black line that we drew right there. So we're going to hold this over very closely. We're going to turn that light on. Let's see what happens. You can do it. You can do it. You can do it. You did it. So we started with a flat shape, and we wound up with a three-dimensional shape. Let's see what happens if we have a pre-printed template here. Now this is flat. What shape do you think that will be when we hit it with the light? Let's find out. Hopefully you'll be able to see this when we turn the bright light on. Here comes the light. Ready? 3, 2, 1. So we formed a cube out of a flat sheet. Pretty interesting. Here's another shape. What shape do you think this will take once we turn it into a three-dimensional structure? Let it warm up a little bit before we stick the light on it. Okay, are you ready? 3, 2, 1. Ideally, that would have formed into the shape of a pyramid, like that, but our folds didn't work all the way. Here's just a little piece with 3 lines on it. Let's see what happens when we put that down and heat it up. Well, that one didn't work out as planned. This piece has the drawings on two different sides, so we'll see what happens if we hit this with the light. So I have one in the middle, and then on the other side are those two on the outside. Let's see what happens here. Check our temperature. So we want to get it close to that temperature where it starts to shrink, and then we're going to use the light to increase the temperature just in the areas that are colored dark. Much in the same way that you feel very warm if you wear dark colors on a hot summer day, the sunshine, that solar radiation is heating up the dark colors, and we're using that same principle to cause localized heating of these black stripes. So let's see what happens now. That one came out exactly as planned. See that? So the side of the printing also has an effect on what happens there, on how it folds. Okay, we're going to try our pyramid one more time. I tried to fill in a little bit because my printing didn't turn out too well, so I'll use the black marker on that. We'll see what happens. Let's get it close to the warm temperature. Alright, so we're right below that temperature where it's going to start to shrink. That would be about 100 degrees Fahrenheit. We'll give it a minute to warm up here, just a little bit more time. You can see right now we're at about 98 degrees. So that's pretty close. Let's see what we do now. Here we go. 3, 2, 1, lights. That one turned out a little bit better, didn't it? There you go. So, three-dimensional shapes from flat sheets with Shrinky Dinks. Self-folding Shrinky Dinks. Pretty cool. So there you have it. Self-folding Shrinky Dinks. Pretty cool. Thanks for watching. Have a great day. Stay safe, everybody, and go Zips.